We're going to have a look at an example of shifting our multiplication by shifting. We're going to do it a naive way where we just go from the bottom up to get the sum, and then we're going to do it in a much more efficient way using this algorithm. Now, you've probably seen a lot of multiplication by shifting. This video is really to hammer home the meaning of this as we go step by step through the multiplication process. Now, if you look at this code, I've set up a little file here. So we've got a byte in A, and that's going to be the value of 2. So that's a very small value, and I picked a small value so that we could see the result of the multiplication, because it's easier to understand when you can see the result. So we're going to times 252 by the value in A, so that should give us a value of 504. Now, 252 is made up of 128 plus 64 plus 32 plus 16 plus 8 plus 4. So there's a lot of powers of 2 going on there, so we're going to have some very repetitive code, but let's get started. So, the value is stored in S0, that's fine. Oh, also you'll notice I've got a little shift print helper here, that's just a little subroutine that I wrote to help print this out in a sort of reasonably pretty way. So, let's get started. So, first thing first, I should multiply, and we're going to do that by shifting. Now I'm going to start from the bottom values of 4 over here and go up to the larger values, so that we can see it increasing as we go along more easily. Now, I'm going to put this in A1. This is just, I'm just picking A1 because this is how I set up the little subroutine to work. And I'm going to move by 2. Now remember, shifting by 2 is the same as doing A times 4. So that's our first step done, the lowest value. I'm going to add that to A0 with the value that's already in A0. A0 is going to be my running total. And then I'm going to add that with the value in A1. So far so good. So that adds to the total. Adds A times 4 to total. So that's the first part done. Now we're going to have very repetitive code, but what I'm going to put in here is print help. Now that'll call my subroutine just to do the printing for me, so I don't have to do it because manual printing is not fun in MIPS. So that's 4 done, so let's do 8. So I'm going to shift left. Again, I'm going to put it in A1, I'm just going to overwrite this as we go. And I'm going to multiply this by 3, and that's going to be timesing by 8. Now I'm not going to put comments in here because we're going to start copying this code because it's going to become very repetitive. And again, I add that to A0. And that's me adding A times 8 to the total. And then I'm going to jump and link to my print help, and that'll do my printing for me. Now, you can see that this code here is basically the same as the code above, but I've changed the powers that we're multiplying by. So I'm just going to copy this so we can go through this relatively quickly. So I need to change this because I've already done 8. So this is A times 8. And then I add A times 8 to total. And this one I'm going to change to 4. Now that's going to give me times 16. So this is going to be A times 16. And then I add to total again. Now if I come down here and do the same again, this is going to be 5, because that's the next power of 2 that I need, and that's A times 32. And then we add that to the total again. Now you can see that this code is very repetitive. I've set it up this way on purpose. This is the way I wanted to lay it out so that we could show it step by step of how you increment this total and then print it out. What I would say is a good idea is maybe to do this in a loop. So you could rewrite this code, looping through each value and using an index to count up to the largest value that you need. But I'll leave that for you to do. And next, we need the power of 6. Oh, and this is going to be, as you might have guessed, A times 64. And then we add that to the total. Let's get rid of this for the sake of some tidiness. And I print again. And this is going to be my last one. It's going to be 7. And that's going to give me A times 128. So far, so good. Now, you can see I've got all of the values here that I need up here. And I've added them to the total at every stage. So I've not commented these add lines, but they're all doing the same thing where they just add what we've just multiplied into the total column. So now, if I turn down the run speed and run this, we'll see this building up step by step down at the bottom here as it prints out the messages. So let's see that happening. So first we add 8, so the current total is 8. Now that's multiplying by 4. Then 16, and that gives us 24, and then we multiply by it again. So we just go through these powers, getting the values, adding them to the sum until we get up to 256, which added on to 248 gets us 504. So I wrote this printer helper so that you could see this building up, adding to the total here to give us the final value. And this is how it works. We build up the result of the multiplication in small stages, adding to the total to build up to the final target value. And this also lets us check that our code is right, and we did get 504. Now, this is a lot of code to write. We copied a lot of it. It's still more than you'd want to have to write, because it's very, very repetitive code. And as I say, you might want to write this out as some sort of a loop, just to get some practice there. But what we'd also want to do is just come up with a much more efficient way of doing this, and we can do that. So let's highlight all this and get rid of it. Oh, if I could type, we might even manage that. Now, we can do 252 this way, or we can do it this way, where we do 252 equals 256 minus 4. So this is the boost algorithm method, the alternate way of doing this, where we go a power above and then we subtract the necessary value from below. So this should give us 252, and it should still give us the result of 504. So let's see how we do that. So we're still going to need to shift, because we need to get the multiplication by 256, which is going to be shifting left by 8 bits. So let's put in A1, value of S0, shifted left by 8 bits. So this is A times 256. So we've overshot the mark. I'm going to add that into A0 with the value that's in A0 of A1. And jump and link to print help. And then I'm going to do the subtraction by 4. Now I still need to multiply A times 4. So let's do that. And we're going to put that, it's going to be from S0, and we're going to shift that left by 2. And then we're going to do subtract. The value of A0 is going to get subtracted by the value that's in A1. And that's going to be A times 256 minus A times 4. So you can see that's going to give us a subtraction, which should be, in theory, equal to A times 252. And we're going to jump and link to print help. So let's slow the speed down again, and we'll see what this does. So assemble it, and if we run, then at the bottom here we should start getting, we added 512, the current total is 512, and then we took away 8, and the total value is 504. So you can see this is a much, much simpler way of implementing this multiplication up here. So you can generally will have two ways of doing this. Either you can sum up the values less than to get up to the total you need, or you can overshoot and subtract. Now it'll depend on the context whether you want to do which way you want to do it, because if it's in between something much lower than 252 and more than 128, it might be quicker just to do the addition. I mean, if it was something like, say, 136, it would be much quicker to do 128 plus 8 than it would be to overshoot by 256 and then figure out how to do your subtraction. Now, you have choices about how you do this and when you do this. Sometimes the question will ask you to do it in one way or the other. It's good to know both methods so that you can save yourself typing a lot of code. So anyway, that's everything for today's lecture. I hope you found this video useful. If you have any questions, please do let me know. Thanks.